Hey guys, I'm Mrs. Delavecchia, and before we start, I want to remind you to take notes using the guided notes that are in your unit packet. Those notes will be a part of your grade. If you have any questions, write them down and we'll go over them in class. So let's get started. In this lesson, we're going to work on solving equations that have variables on both sides of the equation. So to do that, we first need to look and see, are there parentheses in the equation? If so, first step is to get those distributed. Then I'm going to look on the left side, combine the like terms. On the right side, combine like terms. We don't start moving across the equal sign until the like terms have been combined on both sides. But before we start solving an equation, let's take a closer look at what it means to combine like terms. All right, first, a like term is things that can be added and subtracted in an equation. And so those are your constants, which are just your numbers. You can add numbers and subtract numbers. And any variable that is the same letter raised to the same power. So in these terms that I have down here, take a minute and see which ones you think could be combined. So let's start with 2x squared. I've got a variable x and an exponent of 2. So the only thing on here that I could combine that with is this one with an x and an exponent of 2. So I have 2x squared and 1x squared. When there's no coefficient, it's understood that there's one of them. So that could be combined and added to be 3x squared. All right, 3 is a constant, but there's no other numbers here, so it can't be combined with anything. 4x cubed, well, it's raised to the third power. So is this one, but this is an x and this is a y, so they cannot be combined. And then, of course, 3x raised to the first power. We don't write it when it's a 1. It has nothing else here raised to the first power. All right, so now let's take a look at an example. I'm going to look here, and I've got parentheses. So I want to distribute that 6 to the x and to the minus 2. So when I rewrite this, I'll have 3x plus 6x minus 12 equals 2x minus 3 plus 12. All right, next up, I distributed. Now I'm going to look, are there any like terms on the left side? Well, yeah, there's a 3x and a 9x. I mean a 3x and a 6x, which makes 9x minus 12. Over here, I've got a 2x, no other x's, but I have a minus 3 and a plus 12. Those would be combined to make 9. Okay, now I've combined like terms, and now I can start moving to get my variables on one side, my numbers on the other. I like to start by looking at my variable and saying, what's my smaller of the two coefficients? So I've got a 9x and a 2x. I want to get that 2x combined with my 9x. So the opposite of positive 2x is to subtract 2x. So I'm going to keep track of this as my equals. If I do something to one side, I have to do it to the other. So 9 minus 2 is 7. 2 minus 2 is 0. And that leaves a 9. All right, now I'm going to look back at my variables over here. So I'm going to move this number 12 to the other side. Opposite of minus 12 is plus 12. I'm going to do that to both sides. And 12 plus 9 is 21. Then I'm going to look back at my x. It is being multiplied by 7. What's the opposite of multiply by 7? It is divide by 7. And so x ends up equaling 3. Now let's take a look at two special situations that you might run across. And one of them is when there is no solution to the problem. So in this example, again, we're going to look, there's no parentheses, I don't need to distribute, but I do want to handle my left and left side. Those there are no like terms to combine, everything's combined, but I have a 5x minus 3x, so I'm going to say that this side will equal 2x plus 12, and this side equals 2x plus 5. So let's just stop for a minute and think about, well, we're looking to solve for x, which would be a number that when you multiply it by 2 and add 5, it would be the same thing as multiplying that number by 2 and adding 12. So think about how that really could never happen. If I add 5 in one case and add 12 in another, that could never be equal. So let's go ahead and continue to solve and see what this looks like. I'm going to subtract 2x from both sides, and that leaves me no x's there, and then 5 equals 12. 5 doesn't equal 12, so this is what we consider no solution. There is no value for x that could make this equal. Okay, the other case is when I have all real numbers as my end result, and let's see what this looks like. So dividing my two sides, here I do see parentheses, so I'm going to distribute the 2 to the x and get 2x, 2 to 6, and I get 12. Combine like terms with 5x minus 3x becomes 2x plus 12. Now I've got a different situation. A number multiplied by 2 and then I add 12 to it. A number multiplied by 2 and add 12 to it. No matter what number I put in there, it's going to be the same. It's going to make this equal. We'll continue again to solve this and see what it looks like. So if I subtract 2x from both sides, I'm going to have 12 equals 12. Well, yeah, 12 equals 12. So there's no number I could find that's going to make this untrue. So then we say the solution to this is all real numbers. In math, this notation with an R, that's a normal capital R, right? But if it has a double back to it like this, that is the notation for the solution set that is all real numbers. You might also hear people say infinitely many solutions, but all real numbers. So today we looked at solving equations with variables on both sides. We learned that we first need to look if there is anything to distribute and do that. Then we combine like terms, and then we start using opposite operations to get all my variables to one side of the equals and all my constants to the other side. And before you know it, I've solved an equation. All right, that's it. We'll see you in class.